Right, we're at example 8, and we need to shade in the region representing the relationship of the real part of z minus 1 plus 2i plus the imaginary part of z plus 2 plus 3i is all less than or equal to 4. Now you might remember that when we just have the real part of some complex number, then that represents a vertical line, and if we just have the imaginary part, that represents a horizontal line. Now we have them combined here as part of a complete inequation. So it's not going to be a vertical line or a horizontal line. We're going to get a different kind of line. So the best way to do this is to let z, so we have our z part in both of these, let z equal x plus yi, and then we can substitute. We can replace our z with x plus yi and look at the real parts and the imaginary parts and see what we get. Okay, so we have then the real part of x plus yi minus 1 plus 2i plus the imaginary part of x plus yi plus 2 plus 3i, all less than or equal to 4. Now we're looking at this part, it's just the real part. Now the real parts are represented by these bits here, okay, the x minus 1. So we can just write x minus 1 for that bit, and plus our imaginary part for this expression is going to be y plus 3, and that is all less than or equal to 4. Okay, so we can collect some like terms. So minus 1 plus 3 is 2, so we've got x plus y plus 2 less than or equal to 4. So x plus y is less than or equal to 2, y is less than or equal to 2 minus x. And we know what y equals 2 minus x is. It's a straight line. So we're just going to draw our straight line, okay, which is just a sketch here. Oops, not y. Imaginary part of z and the real axis for z. Now we know that it has a y-intercept of 2. I'll just change my pen colour. Y-intercept of 2, and it has a negative gradient, okay, of 1, negative 1, so it's going to pass through the x-axis at 2 as well. Let's see if I can draw a nice straight line. Kind of straight. Okay, so that passes through there at 2, and we know that's 2 as well, with a negative gradient. Now y is less than or equal to that line, so that means we shade underneath our line. Okay, we can always check. Take a point here that's this side of the line, 0, put 0 in place of x and y. Is 0 less than or equal to 2? Yes, it is. So that satisfies, because 0, 0 satisfies that inequation, we know that we can shade that side of the line. Okay, let's move on to our next example. Just need to add another page here. Okay, so example 9. Okay, so example 9, shade in the region on the Argand plane representing the complex numbers z according to these sets of numbers. Okay, again we've got this intersection, so this set of numbers and, okay, so the intersection of or and this set of numbers, so both simultaneously at the same time. So let's just look at them individually to start with. Okay, we have here an inequation with the imaginary parts of z and the real parts of z in the same inequation, so we're going to take the approach, as we did with the previous example, of letting z equal x plus yi. So for this first part, the imaginary part of z, or x plus yi, less than or equal to the real part of z, which is x plus yi minus 1 plus 5i. Now that is all squared, and we'll work through. So the imaginary part of x plus yi will be y less than or equal to the real part of this expression is going to be x minus 1. So it's x minus 1, and that's squared because we've got the squared there. Okay, so now we just can see how it translates from something that looks complicated to something that's very familiar to us. Okay, so that's for this first part. We'll do the same for this part here, so which is the imaginary part of x plus yi greater than or equal to 2, so that translates to y greater than or equal to 2. Alright, we can look at our graphs for that then. So we'll draw the axes. Alright, with our axes here, and we'll have a look. First of all, we've got here a parabola, which is just our basic parabola y equals x squared, but translated 1 unit to the right. Alright, so it's going to be here, and it's going to pass through these points. See if I can get a reasonable looking parabola. Not too bad. That's our parabola y equals x minus 1 all squared, and our other one, which is a horizontal line, and we can do solid lines here because there's less than or equal to and greater than or equal to here as well. We would have known that this is a horizontal line because it's just the imaginary part of z, greater than or equal to 2, so we knew it was going to pass through 2. But within any doubt, we can do this process that we did before by letting z equal x plus yi and working through that. Okay, so y is less than or equal to x, or y is less than or equal to x minus 1 all squared. That means it's going to be below our parabola. Okay, but it has to be at the same time greater than or equal to 2. And so it's below the parabola but above this line. So if we can see that that's going to be this area in here. Okay, below our parabola but above our line. Okay. So we'll leave it at that for this video, and then we'll look at example 10 at least in the next video. Alright.